Problem 19. In figure, C1 equal to 10 microfarad, C2 equal to 20 microfarad, and C3 equal to 5 microfarad. If no capacitor can withstand a potential difference of more than 100 volt without failure. Here, there are two questions. The first question is, what is the magnitude of the maximum potential difference that can exist between a point A and B? And the second question is, what is the maximum energy that can be stored in three capacitor arrangement? So first of all, I'm going to draw the same diagram and we have to consider some information from this question. So first of all, I'm going to draw the diagram. Here we have three capacitor C1 and C2 and C3. And you can see here all these three capacitors are arranged in series. So here we have 2 point A and B. Between this point A and B, we connect three capacitor. C1 takes the value of 10 microfarad and C2 takes the value of 20 microfarad and C3 takes the value of 5 microfarad. And also we have to consider the case what we studied in theory. When you arrange the capacitors in series, the most important thing, the charge stored in each capacitor will be the same. That means in series arrangement, the charge stored in each capacitor will be the same. That means Q1 which is equal to Q2 which is equal to Q3. This is the first point. And also they gave one more information. You can see here these three capacitors can withstand up to the maximum of 100 volt. Clear? And in first question we are going to find what should be the voltage across C3, that means V3 this one, and what should be the voltage across C2 which is V2, and what should be the voltage across C1 and V1. So now in first question we are going to find the maximum potential between the point A and B. That means once you find the answer for this V1 and V2 and V3, we are going to add all these three to get the answer for the first question. That is nothing but our total potential. And also they give the information each capacitor can withstand up to the maximum of 100 volt. Now we should know in which capacitor the 100 volt will be there. So for that we have to use the relation C which is equal to Q over V. This relation is nothing but the capacitance of the capacitor. Generally you can see here C and V have the inverse relation. That means if V increases, your C decreases, right? So that means when you gave the 100 volt, that means when we gave the 100 voltage, and that 100 voltage will be always near to the lowest, the smallest capacitor. So for example, you can see the value of three capacitor. The first one 10 microfarad, the second capacitor 20 microfarad, and the third capacitor 5 microfarad. So out of these three, you can see the C3 is smaller. That means the 100 volt will be near to the smallest capacitor. So we have to give this information first. And after that, what we are going to do, we are going to find the answer for the charge. Once you find the answer for charge of any one of the capacitor, that value will be same for Q1, Q2 as well as Q3. That means when you arrange the capacitors in series, the charge stored across each capacitor will be the same. So that means if you want to find the V1, V2, V3, we need the answer for Q1, Q2, Q3, but V3, at least we have to get the answer of potential. For example, you can see we are going to give 100 volt. So that 100 volt will be always near to the smallest capacitor. So we will get the answer for V3 easily by using this relation. What we get the information from this relation, when you give the maximum potential, that potential will be near to the smallest capacitor. So on that basis, so we can write, as we know, C which is equal to Q over V. So when V increases, the capacitance value decreases. So voltage across C3 is maximum. So that means across C3 the 100 volts will be there. So that means your C3 is smaller here. Your C3 is smaller here. Clear? So by using the value of C3 as well as V3, I'm going to find the answer for Q3. Once you identified the value for Q3, that will be the same value for Q1 and Q2. Clear? So what I'm going to do for getting the answer for V1, V2 and V3, first of all, we have to find the charge. So what I'm going to do, as we know, C1 here is 10 microfarad and C2 here is 20 microfarad and C3 here is 5 microfarad. As we already know, you are near to C3, the voltage across C3 will be maximum. So that means your V3 here is 100 volt. Why? Because as we know, V3, because here your capacitance, when your potential increase, the capacitance will be dropped. That means this 100 volt will be near to the 5 microfarad. Now what I'm going to do, by using this C3 and V3, I'm going to find the value of Q3. Once I find the answer for Q3, as we know, Q1 which is equal to Q2 which is equal to Q3, because why? Here the capacitors, all three capacitors are arranged in series, so the charge across each capacitor will be the same. So now I'm going to use this C3 and V3 for finding the answer for Q3. So let's see what's the value of Q3. So Q3 which is equal to C3 multiplied by V3. Where we got this relation? The general equation C which is equal to Q over P. And here I rearrange this equation in terms of Q. So when you rearrange, you will get this equation. But we are going to find the answer for Q3. So in place of C, I'm going to take C3. In place of V, I'm going to take V3. So now I'm going to multiply the value. So the value of C3 is 5 microfarad. So 5 multiply 10 power minus 6 multiply by 100. So here I got the answer as 5 multiply 10 power minus 4 coulomb. So that's the value of Q3. So now what should be the value of Q1 and Q2? Will be the same, because why? The capacitors are arranged in series. So based on that basis, we can write Q1 also 5 multiply 10 power minus 4 coulomb, and Q2 which is equal to 5 multiply 10 power minus 4, and Q3 just before we find, so better I can write this value here. So Q3 which is equal to 5 multiply 10 power minus 4 coulomb. Now by using the charge, by using the value of the capacitance, I am going to find the value for V1 and V2, because V3 we already know, because V3 which is equal to 100 volt. So now I'm going to use the same relation, but this time I'm going to make this relation in terms of potential. So therefore V1 which is equal to Q1 over C1. So Q1 is 5 multiply 10 power minus 4 divided by the capacitance 1 is 10 microfarad. So 10 multiply 10 power minus 6. Here we got V1 which is equal to 50 volt. Clear? Likewise, I have to do the same relation for finding the answer for V2. So therefore, V2 which is equal to Q2 over C2. The Q2 value here is same 5 multiply 10 power minus 4, and C2 value here is 20 microfarad. So 20 multiply 10 power minus 6. Here I got the answer as V2 equal to 25 volt, and we already know the answer for V3 which is 100 volt. Now what I have to do, I have to find what should be the maximum, the total potential between the point A and A and B. So that will be the answer for our first question. So V total which is equal to V1 plus V2 plus V3. Now I'm going to substitute the value here. So we have the value of V1 as 50 and V2 is 25. So now I have to substitute the value here. So V1 takes the value of 50 volt and V2 takes the value of 25 volt and V3 which is 100 volt. So now when you add all these, your total potential, that means V total which is equal to 175 volt, and that will be the answer for the first question. So that means we have to go back to the diagram, and you can see between point A and B, what should be the potential? Between the point A and B, we got the potential, the maximum, the total maximum potential here is 175 volt. Now we have to find what should be the maximum energy stored in this 3 capacitor. So if you want to find the answer for this question, first of all, we have to find the equivalent capacitance. So better I can redraw this diagram one more time. So we have C1, C2 and C3, and between here point A, point B, and C1 which is equal to 10 microfarad, C2 which is equal to 20 microfarad, and C3 which is equal to 5 microfarad. So here, as we already said, these three capacitors are arranged in parallel. Now we are going to find what should be the maximum potential. That means U max value we are going to find, as we already know the formula for the energy stored in the capacitor, because here we have three capacitors arranged in series. So we have to use the formula because we have the information about the charge and we have the information about the capacitors, right? So we can use this relation Q square over 2 multiplied by C value. But this time, in place of C, we have to find the equivalent capacitance of these three capacitors which was arranged in series. So I have to write this one as C equivalent. So now what we have to do, first I'm going to use this. First I'm going to find the answer for C equivalent, because we know Q1 which is equal to Q2 which is equal to Q3. So that means the value of Q will be the same. So first I'm going to find the answer for this equivalent capacitance. As we know, the capacitors are arranged in series. So the C equivalent, which is equal to 1 over C equivalent, which is equal to 1 over C1 plus 1 over C2 plus 1 over C3. Now we have the value of 10 for C1, 20 for C2 and 5 for C3. And when you substitute the value here, you will get the answer for 1 over C equivalent. So that means 1 over C equivalent, which is equal to 1 over 10 microfarad, which is 10 multiplied 10 power minus 6, plus 1 over 20 multiply 10 power minus 6, plus 1 over 5 microfarad, 5 multiply 10 power minus 6. When you just simplify this value, we will get the answer for 1 over C equivalent. 1 over C equivalent. So here I got the answer as 350 multiply 10 power 3 1 over farad. That is the unit for 1 over C equivalent. But now we need the C equivalent value, right? So that means I have to take the reciprocal value of this. That means I have to take C equivalent, which is equal to 1 divided by 350 multiply 10 power plus 3. So let's see what's the answer for this. So 1 divided by 350 10 power 3. I got the answer here as 2.6. What's the answer here? I got the answer of C equivalent as 2.86 multiply 10 power minus 6 farad. So this is the value for C equivalent. So I can write the answer one more time. C equivalent value here is 2.86 multiply 10 power minus 6 farad. So now I am going to substitute this C equivalent value in the energy storage formula. So let's we go back to the formula. So this is our formula, right? So in this place, what I'm going to do, I'm going to take the value of C equivalent. I'm going to substitute the value here. And also we know the value of charges in the first part. What's the value of charge Q1, Q2, Q3? So all these three charges are same because the capacitors are arranged in series. So we have to take the value which is equal to, that means Q1 we can write here as Q1 which is equal to Q2 which is equal to Q3. Let's we take all these as Q. So that means the value of Q1, Q2, Q3 here we got as 5 multiply 10 power minus 4. Therefore Q value here also the same. So 5 multiply 10 power minus 4 coulomb. So I have to take this value. I have to substitute this value here. When you substitute, you will get the answer for U maximum. That means the energy maximum stored across these three capacitor arrangement. So let's we substitute the value here. So U max, which is equal to 5 multiply 10 power minus 4 the whole square divided by, and here we have to take the answer of the C equivalent, which is 2.86 multiply 10 power minus 6, but we have one more 2 here, so 2 multiply by 2.86 multiply 10 power minus 6. So let's see what's the answer for this. 5 multiply 10 power minus 4 square divided by 2 multiply by 2.86 10 to the power of minus 6. So I got the answer here as 43.71 multiply 10 power minus 3 joules. That means millijoules, right? 10 to the power of minus 3 is the millijoules. If you want to write this value like in terms of milli, you can write 43.71 millijoule. Clear? So this is the answer for this question here, or you can give the answer here itself. But generally, what answer you got from the calculator, just write as it is. No need to write milli or something. Just leave the answer as it is. But this is the answer for this question. Thank you.